For this example, I'm using Crazy Dad Volume 1, Book 100, puzzle number 10. And to remind the viewer, if I have two cells, one of which has to be a star, then I put a circle in both of the cells, and I call that a binary star, and it's a star in this direction, but not a star in this direction. The other is, if I have four adjacent cells, a four square, and if I can determine that there has to be a star in one of these four, then I put this internal symbol in saying that this is what I call a four square, which a star has to be in there somewhere. Excuse me. All right, number 10. First thing we do is look for freebies. And there's 1, 2, 3. So I'm up to 6, and I've only got 1, 2, 3, 4 regions. It's just not working out very well, so that doesn't look too good. Go this way, there's 1 region, 2, 3, but I'm up to 4. So that doesn't look very promising. Let's go this way. 1, 2, 3, but I'm up to 4. Up to level 5, I pick up 1 more, which is not enough. 1, 2, 3, 4. So here I pick up 2 more. 1, 2, 3, 4, 5, 6, but I'm up to row 7, so I can't use that. And in the other direction, similarly. So, bottom line, there's no freebies in this particular puzzle. And there's only one immediate simple form, and that's this guy over here, who is a standard L-shaped region. And that leaves a binary here, which takes out those guys. Now this becomes more tractable because this is 2 cells touching 4 cells, touching a 4 square. So these 2 have to be a star, or at least a binary star, and they take out those guys. And I know that because there's 2 stars in this region and only 1 is noted, that the remaining star has to be in this group of 3. So I call that a 4 square. In these 4 squares, there has to be a star. I also call this a tactical one because it's determined by the shape of the region. Looking down here, we've taken these out, making this the same as this guy, and initially a very small, a very simple shape. So we fill this guy in. And now, when I look at this, here's 2 touching 4, but I've got 2 more down here, so I can't use that rule. 2, this has got nothing simple here, nothing simple here, here. This guy I can get rid of a lot of cells by marking this, but I can't get rid of these 3, so I can't do anything there. Nothing here, nothing here. So I need some other kind of idea to get going here. And what I'm going to do is I'm going to start sort of doing like freebies, but I'm going to go across here and count the number of stars and compare it to the number of columns in this case. So I've picked 4 columns to look at, and let me count the number of stars that are in these 4 columns. There can only be 8. So this is 1. This region makes 2, 3. This region makes 4, 5. This is a binary, makes 6. This region makes 7 and 8. So these guys have to go away, and this one cannot be a star, right? Otherwise we'd get too many stars in these 4 columns. So that makes this guy alive to a star. And we've got this blocked out here. Okay, good. Now, what I'm going to notice, I always look for empty four squares that have all the stars marked out. And I find one candidate here. I actually don't see any other candidates, but let me check this one out. Here's a 1, 2, 3 intersections. 1, 2, 3 intersections. So this is a good one. It's a doubly odd, empty 4-cell. So this is very powerful because I can use it to force a whole lot of other cells. So this has to be a 4-cell, this and this. So each of these has to have a star in it, within that can contact that symbol there. And similarly on both sides. And it also works vertically. This one's already fixed. And that one has pre-existing. So I call these strategic 4 squares because they are forced by the empty 4 square. Now immediately, a couple of nice things happen. This guy who was sitting here by himself is now the 4th cell in a 4 square, of which 3 are already occupied. So this has to be a star. Cross that out. Similarly here, here's a 4 square that has 2 empties, so it has to be a double binary. And any others? Let's see. Right, I don't see any other easy ones there. I do see something I forgot, which is that this star takes out this one. So that makes this a star. These 2 stars in the same row force these guys out. Now that significantly changes this region. This region now has only 2 places for a star, one here and one here. So put the possibility there, and of course it takes out adjacent squares this way. And this is a 4 square with 2 already deleted, so it gets a binary, and a binary kills this. And this is a 4 square with these 2 already gone, so another binary. And you can double check because these 2 rows should have a total of 4 stars. 1, 2, 3, 4. Okay. Now, if we look at this, we have we have a binary and a single star. So they form a 2-star row. And now in this region, we have the classic sort of just 2 here. And we mark out the outer rims of the binaries. Now this binary forced this square to die, and this is a 4 square, so this has to be also a binary. And it forces this guy out too. So we're only left with that one in particular. Now, let's go back to this region here, and it's sort of interesting in that in the whole region there's a binary and half a binary, but there needs to be 2 stars, so this is going to have to be a star. And one of these will have to be a star too. So we've gotten that much done. Now, I think, oops, here's something we can do. Here's a binary and a single. Goes that creates a star here. Okay, here's a binary and a single, and that creates an empty cell there. I think that's about all the ones we have pre-existing. So now, there's no obvious move. Well, I guess I can note this, that this region now has to have 2 stars in it. So that's a star, that's a star, that's a star. That's 4 stars in these 2 rows. So this one has to go out. Okay. Now this region is a problem, so let's see what we can do with this. One of the things I noticed here is that this was 1, 2, 3 regions, but if you look at them, this one is all crossed out to the left here of these guys, 1, 2, 3, 4. And this one is already fully occupied, 1, 2, 3, 4. So basically, in these two columns, we have to have 4 stars, and we've got 1, 2, and so we need to have 2 in here. So this region has to have 2, and they have to all fit in here, which means these guys can go away. Okay? Good. Well, let's see what else we've got here. I do notice over here that we have 4 empty cells and a 4 square, and it's at the 1, 1 intersection, so this is a good one. This is a power one. So we can count up and start making 4 squares, like so. And we notice in this 4 square, we've already got 2 missing stars, so we can do that. Now, we have a star here implied in the 4 square, a star here implied in the binary. That means this can't be a star. So that can go out, creates that. It propagates into this one, which gets that going. So that's all quite helpful. Okay. Let's look up here. I see another possible 4 square with all empties. Let's see where it sits. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a doubly odd. So that's another power 4 square. So that means that it has to have 4 squares here, and it already has them on this side. This one already is half occupied or half deleted, so that becomes a binary. Now we have a binary and a star, so that gets rid of this and gets rid of these. We have a 4 square here, which needs to be filled in that way. It cancels this one, right? Because these two drop out those 2 cells, and that makes this a star. This star and this star go across to get rid of these guys here. This 4 square needs to be completed with a binary, and of course it makes its own contribution that way. And now we need 2 in this region, and so this one is a binary also. We have a binary here and a single star here, so that gets rid of this. And then in this region, we have a binary and an empty, so the empty has to be a star. Okay, that's good. Now, this binary and this single gets rid of that, and that forces this to be a star. It diagonally cancels that. This one has to be a star. This star and this binary form 2 stars. It has to get rid of that. Forces that. And this also forces this and this, which leaves us with these 2 here. There's just filling out the 4 square there. Now let's see, what else can we do? Across there. Oh, here's one. In this column, I've got a star and a half of a binary and no other options. So this has to be a star, and that has to go away. Okay? That's useful. Now, what can we do down here? Now, here's kind of a subtle trick. This pairing of binaries separated by a square, it reminds me of the in chess what's called the knight's fork. If we put a star here, it gets rid of these guys and forces these 2 to be stars, and then we would have 3 in the bottom row. So this star would be illegal. We have to get rid of it. That makes this a star. These 2 get rid of this guy, becomes a star. He gets rid of diagonally this guy, which becomes a star. Now we have 2 stars in the bottom row. They get rid of these 2 and that one. And I don't see any other unfinished binary stars, so we're done.